Now previously we enabled spanning tree because of the redundant links we added to enable link aggregation or trunking between the 5406 and edge 1 as well as the 5406 and edge 2. So as an example, if I telnet to the 5406, log in as manager and type show run, you'll notice that spanning tree has been enabled. The only command we typed was spanning tree enter in global config mode. On edge 1, we typed spanning tree. The system automatically adds these commands: spanning tree, TRK, and the number, and a port priority. So spanning tree has been enabled on all devices simply by typing the command spanning tree in global config mode. So let's find out who's the root of this topology and which interfaces are forwarding and which interfaces are being blocked. So once again, on the 5406 acting as our router, show spanning tree allows me to see spanning tree information. So I'll just hit enter here. Spanning tree has been enabled on this switch. Now because we haven't specified options for multiple spanning tree, by default the switch is running multiple spanning tree but using a single instance. So in other words, it's acting as if it's a rapid spanning tree. Notice the internal spanning tree mapped VLANs are 1 to 4094. In other words, all VLANs are mapped to the internal spanning tree. There are no real instances of spanning tree at the moment. The switch priority is 32768, the default. There's the switch MAC address. The max age timer is 20 seconds. The forward delay is 15 seconds. Remember, by default, spanning tree goes from blocking to listening to learning to forwarding. So the time from blocking to listening is 20 seconds. Listening to learning is 15 seconds. And learning to forwarding is 15 seconds, giving you a total of 50 seconds. The time since the last change in spanning tree was 45 minutes ago. You can see that the spanning tree root has a MAC address of this, which is different to the local MAC address. So the 5406 is not the root of spanning tree. The root priority is 32768, the default. In other words, we haven't changed spanning tree defaults. The path cost to the root is 20,000. The local root port is TRK2. So in other words, the spanning tree root is either edge 2 or edge 3 out of that port on the local switch. If we scroll down, you can see that the switch is forwarding on port A1. It's forwarding on port A5. And if we scroll down further, it's also forwarding on TRK1 and TRK2. So in other words, the switch is forwarding on all ports: A1, A5, TRK1, which consists of port A2 and A4, and TRK2, which consists of port A3 and A6. TRK2 is the root port of the local switch. So in other words, the root of the spanning tree is either edge 2 or edge 3. So let's have a look at edge 2. Show spanning tree. You can see that the switch MAC address ends in 64C0, and the MAC address of the spanning tree root is the same MAC address. So this device, edge 2, is the root of spanning tree. You can also see that it says clearly in the output here that this switch is the root. You can also see that the root path cost is 0. In other words, there is no cost to get to the root because the switch is the root of spanning tree. So scrolling down the list, you can see that port 2 is forwarding and TRK1 is forwarding. All ports on the spanning tree root would be forwarding. No ports get blocked on the spanning tree root. So why did this device become the root? You can see the MAC address is 0016B9. On the router, show spanning tree shows me that the MAC address is 001FFE. So the MAC address of edge 2 is a lower value, 6 is lower in hexadecimal than F, and that's why edge 2 is chosen as the root rather than the router. So on our interfaces, both ports on edge 2 are forwarding TRK1 as well as port 2. Edge 2 is the root of the spanning tree. Let's look at edge 3 and edge 1 to see if any ports have been blocked on those switches. So looking at edge 3, so telnet 10.0.0.103 shows spanning tree. You can see that this switch is not the root. It has a path cost to get to the root. Its switch priority is 32768. And on this switch, port 1 is forwarding and port 24 is forwarding. So both these ports are forwarding on edge 3. Let's have a look at edge 1. So telnet to 10.0.0.101 shows spanning tree. You can see once again that this switch is not the root. It has a path cost to get to the root. Its root port is TRK1. Scrolling down, you can see that port 24 is forwarding as well as TRK1. So in this diagram, all the ports on the HP switches are forwarding. So why is that? Why are no ports blocked? Well, the answer is there are no loops in this topology. It's important to realize that these links, even though they're two physical links, have been configured as a trunk. So there's actually one logical link here as well as over here. Ports A2 and A4 on the 5406 have been bonded together to form a trunk. The same is true on ports 1 and 3 on edge 1. So logically this is one link, and logically this is one link. However, if we added a redundant link, let's say as follows. We add a link between edge 1 and edge 3. So port 2 on edge 3 is connected to port 23 on edge 1. In this case, we now have a loop, and spanning tree will block one of the links. So I'm going to add that link between the two switches, and let's go through the spanning tree output again to determine what's changed in our topology. So I've plugged that link in. Let's look at the spanning tree topology starting with edge 2. So on edge 2, typing the command shows spanning tree. Notice once again this switch is the root of the topology. Just because we've added another link doesn't change the fact that this switch has a lower MAC address than other switches in the topology, and hence edge 2 is still the root. Looking at the interfaces, port 2 is forwarding. Scrolling down, as well as TRK1. So once again, edge 2 is the root of the topology, TRK1 and port 2 are forwarding because this is the root of spanning tree. Let's have a look at our router. So on the router, show spanning tree. Now in this example, port A1 is forwarding, port A5 is forwarding. So both port A1 and A5 are forwarding in the topology. Scrolling down, you can see that TRK1 and TRK2 are also both forwarding. So both the trunks, port A2, A4, which is TRK1, and ports A3 and A6, which are TRK2, are forwarding. So there's no change thus far on the forwarding of ports on the switches. Let's have a look at edge 3. So on edge 3, shows spanning tree. On this switch, the root port is port 1, which would make sense because that port is the closest port to use to get to the root. So port 1 is forwarding. Port 2 is forwarding. So in our diagram, this port and this port are forwarding. What about port 24? You can see that port 24 is also forwarding. So at the moment, there's no change on the topology. All the ports thus far are forwarding. Let's lastly look at edge 1 and see if there's a difference. So on edge 1, shows spanning tree. You can see that the root port is TRK1. So looking at the interfaces, you can see that the new link, port 23, is blocking. So this link to edge 3 is blocking, port 24 is forwarding, as well as TRK1. So this is what our diagram looks like. In the HP network, all ports are forwarding except port 23. Please don't forget that once again these two links are acting as a trunk, so there's a single link here logically from a spanning tree point of view. The same as these two links, they are acting as a trunk, so logically they are a single link. So physically, this is what the topology looks like, but logically, this link is logically unplugged. It's logically not forwarding traffic between the switches because this port is blocked. It's important to remember that only LLDP messages and BPDU messages are transmitted through port 23 on edge 1. The blocked port will not allow other traffic through that port. Once again, only LLDP and BPDUs can transmit through that port, so logically it's as if that cable is not plugged in. When traffic from PC2 needs to be sent to PC3, it will traverse edge 1, router, edge 2, edge 3 to get to PC3. The traffic will not go directly between edge 1 and edge 3 because spanning tree is blocking that port. So why did edge 1 decide to block port 23 rather than TRK1? Well, the reason once again is because of the spanning tree algorithm. The first choice in spanning tree once again is to choose the root in the spanning tree topology. And in this example, edge 2 was chosen as the root. The next decision is all switches choose their root ports. So as an example, on edge 3, port 1 is the root port because it's the closest port or best port to use to get to the root bridge. On the router, the best port to use is TRK2. It's the port with the lowest cost to get to the root bridge. So on the router, once again, if we look at the costs of ports, notice port A1 has a cost of 200,000. Port A5 a cost of 20,000. And that's based once again on the speed of the link. Scrolling down, you can see TRK1 has a cost of 200,000 and TRK2 a cost of 20,000. So in other words, TRK2 has a lower path cost. So I'm going to add the costs to the diagram so that you can see why spanning tree chose certain ports rather than others. So from the router's point of view, the cost of TRK1 is 200,000. The cost of TRK2 is 20,000. From the router's point of view, the best path to use to get to the root will be via TRK2. And if we look at the topology, that makes a lot of sense. It makes more sense for the router to send traffic via this link to get to the root rather than via this, and this link. But let's look at the path costs of edge 3 and edge 1. So on edge 3, show spanning tree, you can see that the path cost of port 1 and port 2 is 200,000. So in our diagram, this link from edge 3's point of view has a path cost of 200,000, as well as this link. Path cost 200,000 on both. So lastly, let's look at edge 1. On edge 1, the cost for port 23 is 200,000. The path cost for port 24 is 200,000, and the path cost for TRK1 is 200,000. So the path costs on all links are 200,000. TRK1, 200,000. Port 23, 200,000. Port 24, 200,000. Now this port doesn't really count because this is going to an edge device, a PC. So looking at the path costs in total, the path cost from edge 1 to the root is 200,000 plus 200,000. In other words, 400,000 to take this path. The path cost via TRK1 to the router and TRK2 to edge 2 is 220,000. So in other words, it makes sense to use this port as the root port on edge 1. It makes sense for edge 1 to send traffic this way rather than this way to get to the root, because this path cost is lower. Now the reason the path cost is lower is because if we look at the speed of the link, so show interface brief, you can see A2 TRK1 is running at speed 100 full duplex. A3, part of TRK2, is running at 1000 full duplex. The same with A4 TRK1, 100 megabits per second full duplex. A4, 1000 megabits per second full duplex. So the cost associated with a gigabit link is 20,000, and the cost associated with a 100 meg link is 200,000. Gigabit links would be preferred because they're quicker. So thus the path cost from edge 1 to edge 2 is lower, total of 220,000, rather than via the path through edge 3, which is running at 100 megabits per second. So total cost 400,000. So once again, in spanning tree we choose the root. Edge 2 is chosen as the root. Then we choose the root ports. The root port for edge 3 is port 1. The root port for the router is TRK2. Physical ports A3 and A6. The root port for edge 1 is TRK1. In other words, ports 1 and 3 physically. But from a spanning tree point of view, this looks like a single link. Once spanning tree has chosen the root ports, it chooses designated ports per physical link. The designated port is the port on a physical segment that is closest or has the best path to the root bridge. So if I logically imagine a PC in the middle of this cable, would it make more sense to send traffic this way or this way to get to the root? And it's fairly obvious that this is the best path to use to get to the root. So in other words, this port is the designated port on this physical segment. What about the links connected to the router? So on TRK2 on the router and TRK1 on edge 2, in other words, these two physical links, which is the best port to use to get to the root bridge? And in this case, it's these two ports. In other words, TRK1 on edge 2. If I had a PC in the middle of this cable, it would make sense to go this route to get to the root bridge rather than going via edge 1 and edge 3 to get to the root. So in other words, this is the designated port on the segment between the 5406 and edge 2. Now once again, what about this physical segment? Now remember there are two cables, but once again, acting as a single cable logically, from spanning tree's point of view, would it make more sense to go through this port or this port to get to the root bridge? So if we look at the costs, let's assume once again that there's a PC at the halfway mark on this cable. So if we go this way, 200,000, 220,000. If we go this way, 200,000, 400,000, 600,000. So in other words, this would be the designated port on this physical segment between edge 1 and the router, because this is the best port to use to get to the root bridge. So in other words, this port is forwarding. What about this physical segment? Once again, if there was a PC at the halfway mark on this cable, this path would be 200,000, 200,000. In other words, 400,000. 200,000, 400,000, 420,000. So this is the designated port for this segment. It's the best port to use to get to the root bridge. It makes sense to go to edge 3, port 2 to get to the root bridge, rather than going to port 23 on edge 1 and going this route to the root bridge.